Hey everyone, welcome back to Everyday Breakpoints, where we find the science hiding in plain sight. You've done this 1,000 times. Leftovers from the fridge, into the microwave.
2 minutes. Start.
You walk away, come back, the plate is hot. Too hot. You burn your fingertip on the edge, mutter something under your breath, and eat your reheated pasta anyway. And the entire time, you've been saying the same sentence to yourself. The microwave heated my food. That sentence is wrong, and not in a nitpicky, well, technically kind of way. In a, you have been misunderstanding a fundamental piece of physics every single day of your adult life kind of way. Your microwave does not heat your food. Not in the way you mean it. And once you see what's actually happening inside that box, you will never look at a plate of leftovers the same way again. But before we get into the physics, let me be honest about something. The food comes out hot. Nobody's debating the result. The question is how it got there. And the difference between what you think is happening and what is actually happening is roughly the difference between a campfire and a radio station. So let's start with what you already know, and then break it completely. When you cook something on a stove, the story is simple. Flame or electricity heats a coil. Coil heats the pan heats the food. Heat moves from the outside toward the center. That is conduction. Your oven does something similar. Hot air surrounds the food. Energy creeps from the surface inward. That is convection. In both cases, thermal energy moves from a hotter object to a colder object. Cold food meets hot environment. Heat flows in. Straightforward. Nobody's confused. A microwave does exactly none of that. And here's the thing that genuinely messes with people's heads. There is no heat source inside a microwave. The air in there is not hot, the walls are not hot, the glass turntable is not hot. So where is the heat coming from? From the food itself. Yeah, you heard that right. The food heats itself. It does this because your microwave is not a heater. It is a radio transmitter. Inside every microwave oven sits a component called a magnetron. It generates electromagnetic waves, the same category of thing as FM radio, Wi-Fi, and cell signals, at one very specific frequency. 45 gigahertz. That number was not chosen by accident. It was chosen because water molecules, the kind that make up most of your food and pretty much all of your leftovers, absorb energy at that frequency absurdly well. Now here is what happens next. And if you take nothing else from this video, take this. The microwaves do not carry heat. They carry an oscillating electric field. When that field meets a water molecule, which is polar, meaning it has a positive end and a negative end, it grabs it, and not gently. It flips it, billions of times per second. Picture holding a magnet next to a compass needle and shaking it violently. The needle spins, slams back, spins again, slams back. That is what is happening inside every water molecule in your food right now. They are being yanked back and forth 2.5 billion times every second by a field you cannot see. And all that molecular violence? It creates friction. The water molecules grind against each other, against fat molecules, against proteins. That friction is what we call heat. So the microwave is not heating your food. It is vibrating your food's own water so aggressively that your food heats itself from the inside. The appliance is just providing the shaking. And honestly, if that does not slightly rearrange your understanding of reality, I do not know what will. But here is the catch. We have all heard that microwaves heat from the inside out, and if that were strictly true, the center of your soup would be boiling while the rim stayed cold. That is not what happens. Not exactly. Microwaves do penetrate food, but only about an inch deep, maybe an inch and a half, depending on what you are reheating. After that, most of the energy has already been grabbed by the water molecules in the outer layer, so the outer inch gets the direct vibration treatment. The deeper interior gets heated the old-fashioned way, thermal conduction from that hot outer layer creeping inward. It is a hybrid system, part dielectric heating up front, part regular heat transfer in the back. This is also, by the way, why you get those maddening cold spots. You know exactly what I'm talking about. The burrito that is lava on one end and straight out of the freezer on the other. That is not your microwave being cheap. That is fundamental physics. The microwaves bouncing around inside that metal box do not distribute evenly. They form what is called a standing wave pattern, peaks and valleys of energy intensity spread across the cooking cavity. Where two reflected waves meet and amplify each other, you get a hot spot. Where they cancel each other out, almost nothing happens. This is why your microwave has a turntable. It is not a bonus feature. It is an emergency workaround. A desperate attempt to drag your food through those peaks and valleys so it does not emerge half magma and half frozen solid. And here is another one while we are here. The metal mesh on the door. The one with the holes you can see through. Why can light escape but the microwaves cannot? The holes in that mesh are smaller than the wavelength of the microwaves. A microwave's wavelength from peak to peak is about 12 centimeters. To waves that size, that mesh looks like a solid metal wall. They bounce right off. Visible light, on the other hand, has a wavelength hundreds of times smaller. To light, those holes are massive doorways. Same box, same physics. Two totally different realities depending on which thing is trying to get through. Now, this next part is genuinely the most fascinating piece of the whole puzzle. Remember how I said water molecules are the primary target? That means anything without freely rotating water molecules barely reacts to microwaves at all. Ice, for instance. In ice, water molecules are locked into a rigid crystal structure. They cannot spin. They are frozen in place, literally and functionally. Put an ice cube in the microwave by itself and almost nothing happens, while the frozen lasagna right next to it turns into the surface of the sun. This is why defrost mode exists. It pulses the microwaves at lower power in cycles, giving heat time to propagate through the frozen parts and melt just enough water molecules to get the chain reaction started. And then there are oils and fats. They are mostly non-polar molecules, no positive-negative split, no dipole for the electric field to grab onto. So they heat up, sure, but indirectly, by rubbing shoulders with the vibrating water molecules around them. They're bystanders getting jostled, not the ones being shaken directly. This is why reheating something greasy like pizza goes so unevenly. The water-heavy tomato sauce turns into molten rock. The cheese, lots of fat, much less water, stays suspiciously lukewarm. Different molecules, completely different rules. So why does any of this matter? Honestly, it probably does not change how you use your microwave tomorrow. You are still going to hit the Add 30 seconds button and walk away. But here is the bigger thing. We move through our lives surrounded by objects we think we understand. The microwave, the fan, the puddle your dog drinks from. We use them every day. We assume we know how they work. And most of the time, we are wrong. Not slightly wrong. Fundamentally, structurally, upside down wrong. The microwave does not heat your food. It sends a radio signal tuned to the exact frequency that water cannot ignore, and your food heats itself. That is not an appliance. That is a magic trick we have all collectively agreed to stop being amazed by. So the next time you reheat last night's dinner, remember what you are actually doing. You are not cooking. You are transmitting. And your leftovers are listening. And that is the breakpoint. Thanks for watching. See you in the next one.